So first thing I want to do is just go over the answers when it comes to drawing the circuit diagrams. Some of you guys have asked me for rulers, just occurred to me. Everybody want some rulers? Help you draw lines. All right, let's start. So, what I just want to do is go over the answers to this worksheet on drawing circuit diagrams. And then I'm going to draw this circuit diagram down below so you guys can see what it's supposed to look like and what answers you guys should have gotten. If you don't have the right answers, that's okay. You can always redraw the circuit on that piece of paper. So, first things first, all lines must be ruled. So where do we see a section where that line is not straight? About right here, right? So that's an example of not a straight line. All right. Number 2, we're looking for correct symbols. Now this here is not a correct symbol. You should have it looking like that. Big line, small line, big line, small line. The other thing that isn't a correct symbol is this light bulb here. We shouldn't see a line going through the X. It should just be a circle and an X. Like that. Tick, tick. All right. Number 3, we should have no overhanging lines. That line over there is overhanging. So that's number 3. Number 4 is no gaps. Here's a gap. Number 5, components should not be drawn in corners. That is something that's being drawn in a corner. Oops, number 5. And then number 6, we should have perpendicular corners. So it should be like square corners, which is what we see over here. So what I'm now going to do is show you guys how that drawing should look if it was drawn properly. So I'm just going to move this down and move it out a little bit so you can see it. So first thing is I need to fix that battery. It should be long line, short line, long line, short line. And then what I'm going to do is I'm going to use my ruler just because I find it's helpful to have it. And I'm drawing 2 straight lines just so that way my circuit can begin. Now, something to keep in mind is that I shouldn't have my light bulb on the corner there. So I'm going to draw my light bulb towards my center. And again, taking my ruler, nice clean lines. All right. Then when I'm looking at this section here, I have a line and then it bridges out into a box. So I'm going to start that process of making that. Now with that box, there are 2 light bulbs. So I'm going to do a light bulb over here. I'll do a light bulb over here. And then I'm going to take my ruler and fill in those lines. Now, unfortunately, I don't have that connecting there, so I'm just going to finish that. So it's all just about drawing straight lines. All right, does that look better? All right, you guys should be drawing something similar as well. Remember, it's supposed to be long line, short line, long line, short line. All right, the last thing I'm then doing is this little corner over here. So doing that. Doing this. Now I'm mindful that the switch is open. So when I draw a switch, I'm going to do little dots. And I'm drawing my little line going out because that's going to be the switch. So that's my switch and it's open. So that's what a clean circuit diagram should look like. And we compare it to the one that was before. We can see how much nicer that one is. So that's what you guys should have drawn. All right. So what I'm going to do is I'm going to build what we talked about, and I'm going to add something known as an amp meter. So actually, yeah, I'll build them so you can see them too. All right. So what did you guys remember out of those 3 light bulbs? Which one was the brightest? Just the one. So here's our 1 light bulb. Very, very bright. Here's our 2 light bulb. Not as bright. I hear music. I shouldn't hear music. You guys shouldn't be listening to music right now. Haven't been told you can do that. So let's put 2 light bulbs down. Like this. Now this is what's called a series circuit. And series circuits only have 1 pathway. So we see that light bulbs are a little bit dimmer. And it's got even dimmer. But we're trying to understand the why. It's going to use up all the energy, yeah.
I'm pretty smart, even though I wasn't even smart. I know my things. I'm just that guy. I'm not trying to.
All right, there we go. So we notice when we're looking at this 1 light bulb is the brightest. Then every time I add a light bulb in series, it gets dimmer, right? Something about the energy is being affected by this. What do you guys notice when we have a circuit? What's happening with these guys? They're moving around. What are they? The electrons. Yeah, so these electrons are moving. What do you notice about these ones versus that? Yeah, they're moving slower. So let's put in an amp meter. Do you guys know what an amp meter is? Amp meters measure current. So I can put them in, and I have to put them in line with the circuit. I can't just like have them going elsewhere. So I notice before the light bulb, it is 0.9 amps, because it's an amp. Do you think it'll matter if the amp meter is behind the light bulb?
Yes.
What do you think is going to happen? Is it going to go? It's going to be the same?
Yes, I already did those cells.
It's the same. So does it matter where I put my light or my amp meter? No, it doesn't. Now we're going to put an amp meter over here. Now what do you think is going to happen with the amp meter? Is it going to read 0.9 as well? It's 45. When we look at that number, how does that number work? Is it? It's going slower. Is this a half, maybe? 2 light bulbs have halved the current?
Most of the energy is like, not going as fast.
Would it matter if I put my amp meter over here?
Yes.
Would I still read 45?
Yep. Yes.
Or would I read something else?
Oh, yes.
Still 45. What about over here? Would it still read 45?
Yep.
Yes.
Yeah, because you know why?
Because it's 45 meters long.
It's a series circuit, so regardless of where I measure the current's the same because it's just one pathway. All right. Using our deduction skills, if this was 0.9, and this one, when I add 2 light bulbs, is half to 0.45. What do you think the current's going to read for this guy if there's 3 light bulbs? 0.9, like this one up here?
15.
15? What else?
Nah, it's gonna be a 20.
It's gonna be 30.
30.
Oh.
Pretty smart.
So who had 0.3 as the answer?
Me.
Me.
Why?
Because I'm smart.
Why? How did you know it was going to be 0.3?
Because I did it.
Because you did it before?
Oh, we did it last week.
Okay, I know you did last week. I'm refreshing it. What is 0.9 divided by 3?
That equals to
3.
0.3.
3.
So do you see how we're taking this current and we're dividing it up? If I broke this right here,
Oh no.
oh, did I run out of ammeters? That's okay. I'll put this one down. This one will work.
What the?
All right, see? 0.3.
Oh, got
So it doesn't matter where we are. It's always the same. But this only applies in a series circuit. So series is only one pathway. That's important to remember. Do you guys know what a parallel looks like? Should I make a quick parallel so you guys can see it?
I'm open. Because I'm that guy.
Oh, shoot that light bulb around. All right, let us do a parallel circuit. I'll add some more wires.
And that's gonna be a highlight. Yes.
I think it's not.
Why is it moving? Why is it moving? Why is it moving?
All right, so what do we know? This is a parallel circuit. So you see how we have one circuit, and then we have this second circuit over here. That's parallel. So there's 2 circuits now. What do we notice in comparison to I'll get rid of this light bulb here. So we have the compare and contrast. So this is a circuit with 1 light bulb. This is a circuit with 2 light bulbs, but in series, so only one pathway. And this is a circuit with 2 light bulbs, but in parallel. So there's 2 pathways in this example. So comparing and contrasting, what do we notice? Is this one or this one brighter? The parallel one's brighter. What about the parallel compared to the single light bulb? Are they the same brightness?
It's the same.
They're the same. All right. What do you guys notice about how the electrons are moving? This one's slow. Is this one? Is it faster than this one though? Is it faster than this one?
It's going awkward.
Yeah, you're gonna find out in our next lesson what does that mean for the current when we're in these little circuits. All right. So going back to our screen for today's lesson, I'll change this to because we're summarizing. All right, and we'll highlight this. No, not what I want to do. There we go. Spotlight this. All right. So just to refresh what we were looking at for today's lesson, we were just refreshing. Oh, we can probably make it bigger. Maybe a bit too big. All right. We were refreshing how current behaves in a series circuit. For you guys to be successful in this lesson, you should be able to make observations about the light bulb brightness. So what do we notice with the light bulb? Every time we added a light bulb, what happened in a series circuit? Did it get brighter or dimmer? Dimmer every time I added more. And then with the current, what happened? Every time I added a light bulb, what happened to the current? Increase or decrease? Decreased. If I measure a current in a series circuit, is it going to be the same everywhere? Yes. All right. And then you guys also practice drawing and making circuits. We drew them on a piece of paper. You also started to build them with the equipment as well. All right. So you guys have met the success criteria for today. So that's what we did for today's lesson. Great work. We'll keep practicing this, okay? All right.